Welcome back to PyLadies Con 2025. My name is Abigail Mishenga and I'm here to introduce our next keynote speaker, Don Wages. Now, before I share about who Dawn is, I'd like to say a big thank you to Dawn for all her work within the Python software community and beyond. Dawn Wages is a software engineer, ethical open source advocate, and community leader. She's the former chair of the Python Software Foundation and currently works as a director of community and developer relations at Anaconda, the largest scientific Python distribution in the world. In a nutshell, Dawn's work bridges technical expertise with a commitment to equity, sovereignty, and collaboration in the developer community. Today, Dawn's talk is titled, Don't Be Everything to Everyone, The Case for Career and Model Specialization. Welcome, Dawn. The stage is yours.
Oh, what an honor to be introduced by you, Abigail. Thanks so much. And hey, everyone. Again, my name is Dawn Wages, and it's an honor to speak with you all today. Let's see. I think you might also hear my dogs excited to hear from you all today too. So let's jump in. So the context of this talk today has come from the last several years. We've all heard, or many of us may have heard, about language models being a larger and larger part of the global zeitgeist. At the same time, in my career and as I've been interacting with more Pythonistas in the ecosystem, I've been asked many questions from people of all genders, expressing concerns about the tech job market and how to make the most of their career. And there's a lot of advice I give. It usually starts with passions and interests, outcomes, and urgency. But really the second phase of those conversations, I use different words, different times, but culminate to understanding your career specialization. So I'm combining two topics that I've been cycling on over the last couple of years into a brand new keynote that I've not given anywhere yet for this audience, because PyLadies is so near and dear to my heart, and I want to talk about model and career specialization. So there's been some research cited for this presentation. This slide comes up again. And if you are interested in following along the slides or looking up the contents of this presentation later, you can also follow the link in the bottom left-hand or bottom right-hand corner. So specialization describes a foundational concept in modern innovation. Most of these definitions that are higher level and will apply to both models in your career and other interdisciplinary subjects will come from economics in my presentation. We are correlating productivity and innovation. A natural curve that we'll find as we are plotting efficiency output with the initial diversity of the industry or the individual or whatever system that we're charting is a typical U-shaped curve. It can be an upside down U based on minimizing resources, defining the efficiency, or maximizing resources, where it would be a standard U-shaped curve. And that will chart the relationship between research and the development efficiency. And but this isn't a perfect model. It's not all up and to the right. There is a competitive advantage that you increase as you get more specific in your analysis or in your input. But then you also may lock into inflexibility. So I'll address some of that in the keynote in the presentation. So here's what we're talking about today, and it's roughly in this outline as well. We'll start with understanding what is specialization, and then we'll apply that to model specialization specifically. This will be large language models and small language models, and then career specialization. And I'll give you tools to apply those model and career specialization through a lens that connect both sides of the aisle. It'll be efficiency through expertise, encouraging small iterations to have big wins in your outcomes, and then really focusing on what does it mean to have sovereignty over your stack and how the specialization emphasizes that. So the problem that I started out with, I'm talking to dozens of people about what their career trajectory can look like. But I'm also sitting at my terminal learning about large language models, small language models in general, just like the rest of the world, trying to keep up with the innovation that's happening in our ecosystem and some of these buzzwords. But there's limitations to the general term of specialization and applying it to us as humans. We are not a single function tool. So as I make some of these analyses, and it will really maybe tickle a certain part of your brain to be pragmatic and thoughtful and think of ourselves as algorithms that we can optimize, we are also not a single function tool. And I want to keep that in mind and keep a human focused approach or lens as we still evaluate some of this analysis and these relationships. There's also a bottom or a top, depending on whether you're minimizing or maximizing output of the curve when you're investing in specialization. Once you get to that point, there's going to be a marginal return that nears and reaches zero as you continue to invest in that specialization. So we'll talk about mitigating techniques, but absolutely we want to think about that. Specialization is not a one-shot kind of tool. And then also, even though we have some opportunities to give ourselves some agency in our job journey, there is no way that we can fully de-risk the job market. And so I say that to say that there is a level of internalization that we take on as problems face us in the ecosystem. And when I'm working with people and mentoring them, I really want to also, this is again that human first approach, I want to emphasize that we are just people kind of trying to make it, and the systems that we live in are not under our control. So we do the best what we can with the resources in front of us. But there's no way to fully de-risk the market. And so what the best way to do it is ask questions, be hungry, and work together. So we'll talk about 3 approaches that I mentioned on the previous slide, and they boil down to efficiency through expertise, iteration, so small iterations to big wins, and then understanding those resources that it'll take to specialize and taking sovereignty over your stack. So specializing can unlock some really key benefits. Higher quality output, for example, reducing error rates, and increasing that skill and expertise. We also want to reduce waste. Specialization can help optimize our resource allocation as we are getting deeper in increasing that expertise. And then on an economic scale, but this can also apply to individual applications, specialization, the cost per unit, depending on what that unit is, because we are taking an interdisciplinary approach, that unit could be something in any number of things. The cost will decrease as we increase our production volume. But again, we are humans, and if we are evaluating a human in the system, there's going to be a limit to that production volume. And I want to be very clear in some of the less human-focused language that we should treat ourselves with kindness, and we are not just algorithms to optimize. But it does provide some analysis to approach it. We can also identify opportunities for improvement. And then when we're working collaboratively or individually, you're finding that you're optimizing towards what could be a competitive advantage. So if the system that you are evaluating and you're looking at homogeneous expertise, where you're deepening that knowledge base, you are now acting as an individual unit. And then when looking to collaborate, you can identify gaps, and then that can lead to more clear interfacing and interoperability with other systems, right? So you can define your output of your system, define input of the other system. So you're in your system A perhaps, and the input of system B. And then you have that transformation layer between system A and system B that can help with collaboration. So let's apply this to the language model process. What I have on the screen is not necessarily the end-to-end. This is specifically about fine-tuning the process, but I'll walk through some of these key points of the language model process for whether you're new to it or you're an old hand. Some of these things can be helpful. So you start with a data set. You'll want to feed maybe a base model. The data set, this could be text, CSVs, scrape files, or domain specifics. Then it'll take that and it'll break the text up into tokens. This could be subwords, characters, or byte parameters. And then those tokens are converted into what are called vectors. Vectors are a list of float values. And what these embeddings will do will capture some of these semantic meanings. And then you'll go into layers. So really the engine inside of that language model process are multiple layers defined in different ways. And you can also add more stacked layers to build deeper abstraction and meaning in your transformer process. But really the common ones that you want to understand across the process, self-attention will take, each token will look at the others to decide which tokens are relevant. And so just as a reminder, the tokens are those subwords and characters that you break up your data set in. And then you'll have this feed forward approach where we'll find the tokens representation. And then residual connections and some of these layer norms will make sure that you're training and you're preventing any type of information loss. Then we'll get into our training process. There's supervised, unsupervised, or self-supervised learning. And that'll relate to whether or not the data that you're inputting is labeled or unlabeled, or if it's unlabeled, if it will label itself and create its own labels, while unsupervised will have unlabeled and it will find data and patterns through clustering. This will be training, the full training process. The goal of that is to predict what is this next token. So when we get to the inference part, when you're actually using your model, what it does is it will go forward and predict each next token. So it turns out to be a probabilistic mathematical problem that we're using with language. In that training, we'll also have a loss function that will measure how wrong our predictions are to make sure we keep them accurate. And then this will require a fair bit of compute. Scaling laws will apply to these things. So usually the expectation is that bigger models, more parameters, more data, and more compute all equal better performance. And small language models also follow this same performance curve. And the scaling laws all apply. So the performance will improve the predictability with size, data, and compute, but the plateaus will come sooner. So small models will max out faster. Balance is also really critical with small language models because you'll need to match the data set to the model capacity. But you'll also find some efficiency wins with small language models where they're often specialized or distilled. So scaling laws will guide how to get the most out of these limited resources. And then the end of that process, that end-to-end, is inference. And so this is when you may be, what is happening? So this is where there's the interface layer. You're building the most user-focused analysis or computation. This step is where you at the terminal or at your text box are providing or providing prompts, and then generative AI is returned to you from that previous work we did. So it is at runtime, you're given a prompt, and the model will encode those vectors, and then it will run through those transformer layers, and then it will output the probability of the distribution over your vocabulary. And it uses different sampling methods, and you'll repeat that process until the response is complete. So it's each word will have a probabilistic return. So you see at the top, we have data, we go all the way to inference, and this is that full end-to-end process that I just described in the previous slides. And there are techniques to specializing in getting optimizing the efficiency, iteration, and resources of these model techniques. So low rank adaptation processes or domain adaptation will apply to the transformation layers and the inference layers. And during this, instead of uploading billions of parameters, for example, what we're doing is we add small trainable modules inside the transformer layers. And so that will allow for more specificity and execution. Also in the inference layer at runtime, that model will use both the frozen base weights, those with the tokens and embeddings and trainings, and the trained low-ranked adapters. You can even swap out some of these adapters in and out for different domains, for example. You can have one adapter for medical text and another one for legal text, for example. Fine-tuning is another opportunity where you can craft So where you can support it without retraining that model. So for example, there's instruction tuning, where you can train that model on data sets of instructions and responses, and it makes the model more helpful and aligned with human expectations. Parameter efficiency will be our next one. I jump around a little bit on this slide. This happens in the transformer layers. This is the main impact point. And so this will have small trainable matrices into attention. So they will be like feed forward. These are parameters. These are the adapters it will add and remove redundant weights. It can distill trains into smaller models and mimic larger ones, and it can drastically reduce the number of parameters during that fine-tuning. RAG is another one that's been really popular around the ecosystem. It doesn't change how the model is pre-trained, but it will, when the user prompt arrives, it'll summarize, for example, latest guidelines. The receiver module will search on some type of external database. And then we have small language models, which I mentioned already before, but it could be trained on much smaller data sets, use smaller vocabularies, have smaller embeddings. For example, you can have thousands of dimensions versus hundreds of dimensions. And then it'll also have fewer layers for transformation and trained on smaller GPUs or CPUs. So let's apply some of these same things or the same lens that we looked at model specialization with your career. It's a similar analogy. We're building a resource bank to input to us. We are that engine, and we can continually iterate through, learn context and semantics in order to apply this to our careers. We can start with general education and gain core skills. We'll move through experience and advanced training, and then we'll specialize, and then we'll have application, hopefully mastery, that will apply to our day-to-day careers. And in those same buckets, efficiency, iteration, and resources, I have some tools, some techniques that you can use in order to continually specialize your career. Like the Pareto principle. This is one where instead of trying to learn everything, you can identify 20% of skills that may drive 80% of results. This can happen, may show up in your advanced training and specialization mode, methods of your career advancement. And there's that chart that I have in the top right-hand corner next to the text, and that is a Pareto curve. So when you are moving out towards being on that optimized curve, you are now leveraging the minimal amount of resources used with the maximum amount of efficiencies. And this borrows from economic principles, and there's a lot of research out there applying it to many different disciplines that will talk about the minimal amount of resources and the maximum amount of efficiency. An example of which would be maybe a senior software engineer specifically focusing on system design and leadership rather than learning every new framework. You end up adapting quickly without burning out your energy on low value tasks. Knowledge base. I love creating a knowledge base for myself. I do this every time I start a new open source project and I know that I want to contribute to it and I'm learning deeply. I will create a GitHub repo. You can have your knowledge base of choice, and you can start providing yourself with the resources to take personal notes, create curated resources, add mentorship to your networks, and that will streamline how you apply your mastery. You can use templates, playbooks, frameworks. For example, a strategy consultant will develop reusable decks or a analysis framework that they're using time and time again. And you can also apply that to the way that you're approaching new disciplines in your code or your Python journey. Teach to learn is a really fun one. That's actually what I was using this presentation for. So as I am learning about large language models and getting my hands dirty with all of the fun new technology and tools, I love to quickly iterate through teaching about what I just learned to solidify the knowledge that I just attained. It reinforces mastery while scaling your impact. Pruning is a way to cut some of that low value work. So if you're identifying tasks that don't really contribute to your long-term goals, you have the opportunity to either delegate, automate, or eliminate them. This keeps your career model clean and lean. And this is one that directly addresses the lock-in that you may have with specialization, domain flexibility. So with domain flexibility, I like to add small iterative modules or opportunities to learn adjacent technologies and then evaluate the effectiveness of learning those adjacent technologies. For example, I am a Django nut, and I've been learning Django for a long time. And as I'm moving into a new field, learning about language models that's been kind of dictated by some of the career growth that I've had, I try to tie it back in iterative cycles to other tangential competencies. And then I see whether or not that fits in with my career goals. An example of that would be a senior software engineer specializing in APIs, and then moving towards certification for security and small iterative cycles. And then the scaling laws also apply to career techniques as well. More effort doesn't always equal more results. So you can balance some of these skills with the experience and data that you collect after each of these attempts and gaining new skills, and then the compute or your energy and time input on it. This avoids burnout and hopefully maximizes your returns. So we're back to these key themes. Efficiency through your expertise, similarity clustering through these heterogeneous activities. So heterogeneous would mean all of these very similar activities. This means we are deepening our expertise and increasing efficiencies. The graph on the right is from industrial activities from German company planning regions. And so they are looking at the diversity in their industrial diversity versus industrial similarity, and then plotting the efficiencies. Conversely, there's also a hypothesis where diversity is expected to have a more stimulating effect. So the way that I've approached that in one of the previous slides we talked about was where you were building niche, and then you are now thinking about interfaces with other expertise. So as you are now evaluating as a closed system, and you are optimizing in that closed system and building efficiency where you do need to find expertise outside, you now have the ability to think about outputs and inputs and then the interfaces with these other closed systems. And that creates an opportunity to fine tune your input and understand your desired output. Small iterations and big wins. So I recommend creating many opportunities for check-ins, and when with practical real-world applications for your optimization strategies, whether it be your model or your career. And then set big wins, set big goals, dream big, write down your hopes and your future plans, very similar to when you are being specific about what you want to build your model to solve for. You are also dreaming big and understanding what all of this input and effort will culminate to is important to understand your objective and will help you get there faster. You can weight your activities, you can offload domain knowledge, you can reduce some of that context size by tailoring to your specific fields, and then you can focus your energy on tokens or concepts in your career with high relevancy. And then take sovereignty of your stack. This is fully resource driven. If you're being thoughtful about the resources that you're using to tune your toolkit, so your software machine learning stack or your career toolkit, you have different levels of ways that you are investing in your career, these resource levels. And by taking ownership of it, you have the ability to reduce friction and have portability. If you're applying it to your software, it allows for control and compliance, resilience, optimization. And if you're applying it to your career, that may allow for autonomy, again, resilience, or you are able to have the ability to negotiate with your career portability. So in this, I recommend that you focus on efficiency, iteration, and owning your stack. Just treating yourself like a system that you are optimizing for as well. The same principles that make specialized models powerful can make your career and your personal growth incredibly resilient. So in conclusion, your language models and your careers, I recommend focusing on high impact habits for your career, iteration through learning and building knowledge bases. And in your large language models, I've given some practical examples on how the industry is refining and making efficient and specialized models, like fine tuning, among many others. And consider your resource environments. What brings you steps closer to optimize and building in this fast-paced discipline? Thank you so much for the time. It's been a pleasure talking to you all. Hopefully you learned something, and I'll continue to talk more about this on my channels. And I love PyLadies, so shout out to all of the organizers. This is such a huge task to put this on every year, and I'm just thrilled to be invited and to get to know you all. Thank you.
Yeah, awesome. Thank you so much, Don, for sharing. I personally loved how you weaved a real world situation of specialization and then the concept of language model process. So, I mean, because for someone like me who doesn't do a lot of data engineering, it was still like very relatable. So, thanks for sharing. We have two questions for you, but due to the fact that we are time now, we would encourage you to please hop on our Discord channel and then kindly help us answer those questions like on Discord as well. But it was very nice chatting with you. Thanks for sharing a lot of insightful things on your keynote. And hi, everyone. Thank you once again for being on this journey with us. Stay tuned for the upcoming sessions. Bye.